Hi everyone. Today we're going to describe the type of relationship indicated in a balanced chemical equation. We're going to state the mole ratios in a balanced equation, and a good vocab to review is reactant, which is a starting substance in a chemical reaction, and these are the new terms. So to get started, we're going to look at the focus for today. And you have the reactant and you have a product. You have A plus B gives us C and D. Are there enough nuts and bolts in the assemblies on the left to make the assembly on the right? Okay, so let's look at A. These are similar. And D, A and D, they're similar. We're starting with 1, we're ending up with 2. So if we want to end up with 2, we cannot start with 1. We need to balance it out. So we need 2 of the A's to make 1 of D. So the answer to number 1 is no, we don't have enough. And it says, what's the minimum number of each reactant? Nuts and bolts is simply will we need. Okay, so we already know that for A we need 2, D we need 1. And then for C, we're starting with 2 and we end up with 1. So we have enough of B to make C. But to balance it out, you need 2 of the C and 1 of the B assembly.
Stoichiometry, the study of quantitative relationships between the amounts of reactants used and products formed by a chemical reaction, is based on the law of conservation of mass.
Now, it's the amount, the number of moles is what we're dealing with. The quantitative relationship in a reaction is what we're dealing with today, stoichiometry. Now, at the end, we have to have the law of conservation of mass to be observed. So reactant has to equal the product. Now, the reaction will keep on going until one of the reactants run out. So stoichiometry is based on the law of conservation of mass, and we're going to
Mole
be
ratio. In a balanced equation, the ratio between the numbers of moles of any two substances.
okay. So first we have to balance the react, make sure it's balanced, and if there's coefficient, that means it's balanced. And then we have the relationship of the ratios and any other two substances. So let's see how we. So this is problem number 1. Interpret the following balanced chemical equations in terms of particles, moles, mass, and show that the law of conservation of mass is observed. All right, so the first reaction. Now we know it's balanced. Now if it's not balanced, then you won't see any of the coefficients. So you have coefficients, it's balanced. So now we have to start with number of moles. So you have 1 of N2, 3 moles of H2, and 2 of NH3. Now we start looking up the mass from the periodic table from N. N is 14, but we have 2 of them. So 2 times 14 is 28. For the hydrogen, there are 2 times 1, but then also times 3, so we have 6. For NH3, N is 14, hydrogen is 1, but times 3 is 3, and we add them up 17. But the coefficient is 2, so it's 34. The law of conservation of mass, then we add everything on the product side and everything on the reactant side, and they have to be equal. So this is the reactant side and this is the product side, and 34 equals 34. So law of conservation of mass is being observed. Okay, so we got 34 because we added the hydrogens and the nitrogen, and that's 34. Let's do one more. There's 1, 1, 1, and 1. The coefficients are 1 in all of them, so that's the number of moles. 1 hydrogen, 1 Cl, we add them up. 1 potassium, 1 oxygen, and 1 hydrogen, we add them up. But that's on the reactant side, so we add 56 plus 36, 92. 1 potassium, 1 chlorine, we find the mass and we add them up. 2 hydrogen, 1 oxygen, we add them up. And then, because both of these are on the product side, we add them up. 18 plus 74 is 92. The law of conservation of mass is being observed. I think that's the last one of this example. Now zinc is by itself, but then we have 4 of them in the coefficient, so we multiply by 4, we get 260. There's 1 hydrogen, 1 nitrogen, and 3 oxygens. We add them up, but then we have 10 of them, 10 moles, because the coefficient. So we multiply 63 by 10, we have 630. Now for 1 zinc, 2 nitrogens, and 6 oxygen, we add them up. Oops, sorry. And then there's 4 in the front, so we multiply by 4 is 756. And then on this side is 2 nitrogens, 1 oxygen, we add them up. There's 1 in the front, so you just bring it down as 44. 2 hydrogen, 1 oxygen, add them up, but then we multiply by 5 because of the coefficient, that's 90. All these 3 have to be added up. 756 plus 44 plus 90 is 890, which is the same as the reactant side. The law of conservation of mass is being observed. Okay, so that's one type of problem. The second type of problem is mole ratios. Determine all possible mole ratios for the following balanced chemical equation. All we have to do is we look at it's 4 to 3 to 2. So let's see how you do this. It's good that you have a system. So we start with aluminum divided by oxygen. That's the first mole ratio. And then aluminum divided by aluminum oxide. That's the second one. Okay. Then we take the oxygen divided by aluminum. Oxygen divided by aluminum oxide. That's the fourth. And then we take aluminum oxide divided by aluminum, and then aluminum oxide divided by oxygen, and that's number 6 mole ratio. So in this case, we have 6 mole ratios. So we take each one of them and divide it by the other 2. Okay, let's just try one more. Okay, now we take the iron divided by water, iron divided by iron oxide, iron divided by hydrogen, and that's the third one. For the second one, we go water over iron, that's number 4. Water over iron oxide, that's number 5. And water over hydrogen, and that's number 6. Okay, we go to this column, and that's iron oxide. So iron oxide over iron oxide over water, that's number 8. Iron oxide over hydrogen, and that's number 9 right here. And then the last column, we have hydrogen over iron, that's number 10. Hydrogen over water, that's 11. And hydrogen over iron oxide, and that's number 12. So in this case, when we have 4 of them, 2 on the reactant, 2 on the product, we have to have 12 of them, 12 mole ratios. Let's see. This one, same. So we take mercury. No, I'm sorry. We take mercury oxide divided by mercury, and then mercury oxide divided by oxygen. That's number 2. And then mercury by mercury oxide, and then that's number 3. Mercury divided by oxygen, that's number 4. And then oxygen divided by mercury oxide, and then oxygen divided by mercury, And that's the last one right here. Okay, and that's more ratios for today and the law of conservation of mass. Hope that helps. Thank you.